Hello students, in this video I will talk about Newton's second law of motion. So first of all, let's start with the quick review. You know about natural state of any object. First is rest and second one is uniform motion. If I want to disturb the state of the object, I need to apply an unbalanced force. Unbalanced force may create velocity to the object, and if there is a change in velocity, definitely I will observe an acceleration. Okay, so let's start with the concept now. Students, I will tell you two approaches for derivation of Newton's second law of motion. In this video I will be discussing only first approach. Okay, so first of all we will determine a relationship between acceleration and force acting on the body. So let's take an example. As you can see here, a cyclist is at rest initially. So velocity related to him will be 0, as well as acceleration is also 0. What if I apply, or what if the cyclist apply force to the pedals? Okay, the amount of force is 5 Newton. Definitely cycle will be in motion, and suppose after the force is applied for a time period of 1 second and the change in velocity means the final velocity is now 10. So what will be the acceleration? V minus u upon t. Put the values and you will get the acceleration as 10 meter per second square. Another case, same cyclist now applies more force on the pedals. Okay, for the same period of time, now velocity is increased. It is increased to 20 meter per second. Time period is same. So definitely acceleration is going to be increased. So what you can conclude from here, that acceleration is directly proportional to force. More force, more acceleration will be produced. Okay. So now we will derive a relationship between acceleration and mass. Suppose a football is there. The weight, the mass of the football is 1 kg. Okay. Now, if I try to move this football, it is very easier for me to move it. Okay. So, less mass, more velocity, more acceleration. What if I have a heavy football? The mass of this football is near about 20 kg. Okay. Now I am trying to push this. I will be able to push this, but velocity is less, so acceleration is also less. So आपने देखा होगा कि अगर किसी heavy object को आपको push करना होता है, तो you need to apply more force, but फिर भी जो velocity associated to that object, it is very slow, है ना? तभी होता है कि जैसे हेवी ट्रक है और एक 2 व्हीलर है या 4 व्हीलर है, कार है ना? अगर दोनों सेम स्पीड के ऊपर जा रहे हैं तो भी हमें लगेगा कि ट्रक की जो स्पीड है, इट इज वेरी डिफिकल्ट फॉर ट्रक टू मूव विद अ फास्टर स्पीड. यस और नो? सो व्हाट कैन आई कंक्लूड हियर? एक्सेलरेशन इज इनवर्सली प्रोपोर्शनल टू मास. ओके, सो नाउ वी हैव गॉट बोथ द रिलेशनशिप. Combine both of them. So I can write A is proportional to F, but inversely proportional to mass. Okay. In science, children, when we have this proportionality sign, okay, this proportionality sign is being removed. Okay, and we get an equal to sign. So before that, we will cross multiply here. So F equals to, you will get directly proportional to mass into acceleration, but I need to remove this. So when proportionality sign gets removed, we get an equal to sign and a constant. So here I have written a constant as K. The value of this constant is 1. Okay. So therefore we have got our final relation, that is F equals to mass into acceleration. This is the required relationship for Newton's second law of motion. So, according to this law, the force acting on a body can be termed as product of mass and acceleration. Okay, so I hope the concept is clear to you. Okay, in the next video I will take second approach. Thank you.